Greetings everyone. In this video, we are going to take a 10,000-foot view of cloud computing. The goal is not to make cloud computing sound mysterious or overly technical. The goal is to understand what it is, why organizations use it, and what risks they need to consider before moving systems into the cloud. As we move through the video, think about cloud computing as a different way to access technology resources. Instead of buying and maintaining every server, storage device, database and software system yourself, cloud computing allows you to use many of those resources over the internet, usually from a provider that manages much of the underlying infrastructure. Cloud computing is the delivery of computing services over the internet. These services can include servers, storage, databases, networking, software, analytics, security tools, and many other technology resources. Instead of needing all of that hardware and software in one local building, an organization can access those services from a cloud provider. A simple way to explain cloud computing is this. Instead of owning every piece of technology, you rent or subscribe to the services you need. If you need more storage, more computing power, or a new software platform, you can often request it quickly through an online portal instead of purchasing and installing physical equipment. This is why the cloud has become so important. It changes technology from something that must be purchased, installed, and maintained upfront into something that can be accessed on demand. That does not mean the physical computers disappear. It means the hardware is usually located in large data centers operated by cloud providers, and users access those resources through the internet. You can think of the cloud as someone else's computer. One of the biggest shifts with cloud computing is the move from ownership to access. In a traditional IT model, an organization often buys servers, installs them in a local data center or server closet, configures the operating systems, maintains the hardware, applies updates, and plans for future capacity. That approach can work, but it often requires large upfront costs and careful long-term planning. In a cloud model, the organization accesses technology as a service. The provider owns and operates the large-scale infrastructure, and the customer uses what they need. If the customer needs more computing power, they can request more. If demand drops, they can reduce usage. This makes technology more flexible because the organization is not locked into a fixed amount of hardware that was purchased months or years earlier. Cloud computing is not magic. It is still built on real servers, real networks, and real storage systems. The major difference is who manages those resources and how users access them. When we talk about the types of cloud computing, one important category is the deployment model. A deployment model describes where the cloud resources are located, who owns them, and how they are used. A public cloud is the model most people think of first. Services are provided over the internet by companies such as Amazon Web Services, Microsoft Azure, or Google Cloud. The provider operates a large infrastructure, and many different customers use services from that environment. A private cloud is different because the cloud environment is dedicated to one organization. It may be hosted in the organization's own data center, or it may be managed by another company, but the key idea is dedicated use. A hybrid cloud combines private and public cloud environments. For example, a company might keep sensitive systems in a private environment while using public cloud services for web applications or analytics. Multi-cloud means using more than one cloud provider. This might happen because different providers offer different strengths, or because an organization wants to avoid relying too heavily on one vendor. Another way to classify cloud computing is by service model. Service models describe what level of technology the cloud provider delivers to the customer. The three classic service models are infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service, or IaaS, gives customers access to the building blocks of computing, such as virtual machines, storage, and networking. The customer has more control, but also more responsibility. Platform as a Service, or PaaS, provides a managed environment for building and deploying applications. The customer focuses more on the application and less on the servers underneath. Software as a Service, or SaaS, is the most complete service from the user's point of view. The provider delivers a full application over the internet. Examples include web-based email, online office tools, customer relationship management systems, and learning platforms. With SaaS, users usually do not manage the infrastructure or the application code. They simply use the software. Cloud providers offer many services, but most of them build on a few core categories. Compute services provide processing power. That might mean a virtual machine that acts like a server, a container that runs a packaged application, or a serverless function that runs only when triggered. Storage services give organizations places to keep data. Some storage is designed for files, some for large objects like images and videos, some for backups, and some for long-term archives. Database services are also central to cloud computing. Instead of installing and managing a database server from scratch, organizations can use managed database services that handle many maintenance tasks. Networking services connect cloud resources together and connect users to those resources. Security and identity services control who can access systems, what they are allowed to do, and how activity is monitored. These services matter because cloud computing is not just about renting a server. It is about combining services to build reliable, secure, and scalable systems. A cloud solution usually combines several services. Imagine a college registration system, an online store, or a web application. Users interact with the application through a browser or mobile device. Behind the scenes, compute services run the application code, database services store records, and storage services hold files and backups. Networking services make sure users can reach the application and that traffic is routed to the right place. Security services control access, encrypt data, monitor activity, and help detect suspicious behavior. In other words, a cloud system is not usually one single service. It is a collection of connected services that work together. Cloud computing offers several major benefits. One of the most important is scalability. If an application suddenly has more users, cloud resources can often be increased quickly. If demand goes down, those resources can be reduced. This is much more flexible than buying fixed hardware and hoping it is the right size. Another benefit is cost flexibility. Cloud computing can reduce the need for large upfront purchases of servers, storage systems, and data center equipment. Organizations still need to manage costs carefully, but the cloud allows them to shift many expenses toward usage-based or subscription-based models. Cloud computing can also improve speed and agility. Teams can create development environments, test systems, databases, and storage resources much faster than in many traditional environments. It can also support remote access and collaboration because users can reach cloud services from different locations. Finally, cloud providers offer access to advanced tools, including analytics, artificial intelligence, automation, and security services that might be difficult for smaller organizations to build entirely on their own. Cloud computing is not only something used by large technology companies. Businesses use the cloud in practical ways. They may back up important files to cloud storage, host websites on cloud infrastructure, run databases in managed cloud platforms, or use cloud-based accounting, communication, and customer management software. This everyday connection matters because cloud computing can sound abstract at first. But once you realize that many familiar tools depend on cloud services, the concept becomes much easier. The cloud is not just a technical trend. It is part of how modern software, business operations, education, entertainment, and communication are delivered. Cloud migration has real benefits, but it also introduces risks. One of the biggest risks is security misconfiguration. Cloud providers offer powerful security tools, but customers still have responsibilities. If permissions are too open, storage is exposed, passwords are weak, or monitoring is missing, sensitive data and systems can be put at risk. Cost is another risk. Cloud services can be cost-effective, but usage-based pricing can surprise organizations that do not monitor their environments. A server left running, storage that keeps growing, or data transfer fees can increase costs over time. Compliance is also important. Organizations must know where data is stored, who can access it, and what laws or regulations apply. Migration can also create disruption. Moving systems to the cloud affects users, applications, data, networks, and business processes. There is also the risk of vendor lock-in if an organization becomes heavily dependent on tools that only exist in one provider's ecosystem. Finally, teams may need new skills. A successful cloud migration is not just a technical move. It is an organizational change. A safer cloud migration begins with clear goals. An organization should know why it is moving to the cloud. Is the goal to reduce hardware maintenance, improve scalability, support remote access, modernize an application, improve disaster recovery, or launch services faster? The answer affects the migration plan. Before moving systems, the organization should inventory its applications, data, users, and dependencies. This step is important because applications often rely on databases, file shares, identity systems, network rules, and other services that may not be obvious at first. Missing those dependencies can cause problems during migration. A strong migration plan also includes security, compliance, and cost management from the beginning. Teams should test migrations before moving critical systems, create rollback plans, document responsibilities, and provide training. The main idea is simple. The cloud can be powerful, but it works best when it is approached thoughtfully and intentionally. To close, cloud computing is best understood as a service-based model for accessing technology resources over the internet. It allows organizations to use computing power, storage, databases, software, and other services without owning every piece of physical infrastructure themselves. The most important categories to remember are deployment models and service models. Deployment models explain where the resources are located and who controls them. Service models explain what level of service the provider gives to the customer and how much responsibility remains with the customer. Cloud computing can offer scalability, speed, remote access, availability, and cost flexibility. At the same time, migration requires serious planning. Security, compliance, cost control, downtime, vendor lock-in, and team skills all matter. The strongest takeaway is this: cloud computing is not simply a place to move technology. It is a new operating model for how technology services are delivered, managed, and improved. Thanks for watching. Cheers.